Let's trace our first class. Here in Unit 4, we have this demo program called Square and SquareTest. Really, this web page should be thought of as two separate files. Everything above this line is typically saved separately from what's below the line. Above the line, this would be called a client program because it has a main method and it's meant to solve a purpose, have a purpose, and execute and do something. Below the line, it's just a regular class. It's really the definition of a data type that the programmer wants to add to his or her copy of Java, if you will. So for some reason, a class developer decided that he or she needs a Square class, and we're going to test that Square class with the client program that's up here. So just keep in mind that normally this would be two separate files, but to combine it into one web page, I made it easier for us to trace and analyze. So here we go. We're going to trace the main method by executing its code line by line. First, you see we have a line of code that declares a variable named block. And instead of being an int or a double or some other primitive data type, it's a square. So its data type is square. Square does not exist in Java. It's not a built-in class. It's not a built-in data type of any kind. It only works here because the Square class is typed out and referenced here in the same file, or at least in the same folder as a separate file in your workspace. So what does the right-hand side of the equal symbol do? Instead of setting block equal to 0, or the word Bob, like you would set a string equal to something, block is initialized. More properly, we say that it's being instantiated. So the variable block is brought to life as a square. And we do that by calling the default constructor that's in this class. The default constructor is a sort of a method that has the same name as the class it's in. Notice the name square matches the name of the class. And the default constructor has no parameters. So we are calling the default constructor here with no parameters. And this, furthermore, the default constructor is setting a variable mywidth equal to 0. Well, this variable mywidth is found down at the bottom of the class. The variable mywidth is found at the bottom of this class in a declaration statement. Typically, instance variables, as it's really called, I sometimes call it a property. Typically, they're typed out at the bottom of a class, or they're typed out at the very top of a class, above all the methods in that class. So mywidth we see is a double, and it's private. We'll talk about that later. And because you never should set your properties, your instance variables, equal to numbers in their declaration statements, like down here, it's being set equal to 0. That's the proper place to set a property equal to 0. Okay, so let's continue tracing the code. Block is now a square that has a property called mywidth, which is equal to 0. The next line of code here in the client program declares box as a variable with the data type square as well. But it does so by calling the other constructor. In other words, a constructor that takes a parameter. This 3 is being passed down to the formal parameter width, and because the 3 is being plugged in for width, and because assignment statements work from right to left, 3 is being plugged into mywidth. But don't be confused. The variable box has a mywidth property equal to 3. Sorry about the sloppy handwriting here, but mywidth is equal to 3 for box. Whereas for the square object variable, it has a mywidth property equal to 0. Keep in mind that it's perfectly legal and very common for two object variables, to have instance variables with the same names. It's just the way it is. Their values are different though. We have a 0 here for my_width and a 3 for my_width in the box object variable. Square and object are object variables, and my_width, they are instance variables, also known as properties. Let's continue tracing our code in the client program. The line of code block.setWidth4. That causes the setWidth method found down here towards the bottom to execute, and the number 4 is being passed as a parameter which plugs in for width. Now don't be confused by this either. The fact that I have a parameter named width in my square constructor here, and I have a parameter named width in my accessor method named setWidth. Perfectly fine. They don't have overlapping scopes, the parameter width, and it's just perfectly fine. Well, you see by scrolling down here, which I can't do right now, that the property my_width is being set equal to width. Again, we have a line of code that works from right to left, but this time the value 4 is being plugged into my_width. Well, because this line of code in the client program is invoked by using block as the name of the implicit parameter, in other words, we're calling setWidth on the variable block, you have to carefully keep in mind that, the name of this object variable should have been block and not square. Anyway, the line of code right now that we're executing, block.setWidth4, we come over here at block and we look at its my_width property and we cross it out and make it 4. Box, of course, is a totally separate variable and it still has a my_width of 3. Next line of code, system out print box.getWidth. Box.getWidth causes a 3 to print out because even though I erased it, the variable box currently has a property value of 3. And the next line of code, block.computeArea, produces a 16. Let's look at the method called computeArea. Well, computeArea is a method that does not accept any parameters, but it does return something. I call those kinds of methods interesting methods. And my_width times my_width executes. Well, you have to keep in mind that because we're calling this method with block, and because block's width is currently 4, and 4 times 4 is 16, that's why a 16 is returned by the computeArea method, and a 16 prints out because of that call statement. Last of all, we have the line of code box.computePerimeter. Well, we're talking about box again, and box currently has a width of 3. Its width never changed from its initial 3 that the other constructor assigned to its my_width instance variable. And because we're calling the computePerimeter method, let's scroll down and look to see what it does. The computePerimeter method accepts no parameters, but it returns something. It returns my_width times 4. Keep in mind that because we're executing the line of code here with box.computePerimeter, we are taking box's my_width, which is 3, and we're multiplying it times 4 to get a total of 12. And it's a 12 that's being returned from this return statement back up to wherever we just called computePerimeter. So a 12 ends up filling in the parentheses here of the system out print, and therefore 12 prints out. There we have it. This program, the client program that you see, was a pretty simple first example of a program that instantiates 2 object variables, each instantiated by calling a different constructor that was found in the class. And we called a modifier method named setWidth, we called a accessor method named getWidth, and two interesting methods, as I call them. I'll note as well that modifier methods are typically, especially for a good beginner style, modifier methods are typically named with the prefix set. And then the name of the property or instance variable that's being modified or changed is typed as the whole word part of the name of that modifier method set with. On the other hand, accessor methods, whose job it is to return an underlying value that's stored in an instance variable, they are usually named with the prefix get. And again, the name of the property that you're getting is used as the main part of the name of an accessor method. Accessor methods get something, get it, they get access to, and modifier methods set something to something. They change a value. Interesting methods, on the other hand, or just plain methods that are not accessors or modifiers, they have any name that you want. Often it's a verb like compute perimeter or divide in half, or if you had a zombie class, you might have a method called eat or a method called walk. So we have two interesting methods, both with good names, and that's the wrap.